This call is now being recorded.
Okay, so we will discuss page 14. Okay, look at, we have diagram 1.1 shows a spoon appears bent in water due to a light phenomenon. So what is a light phenomenon? So phenomenon of wave, we have 4 types: reflection, refraction, diffraction, and interference. Okay, so answer here is refraction of light lah. Okay, next, state a physical quantity that changes when light propagates from water to air. So what is changed when the light travels from the air to the water? What is changed here? Okay, when we have different density, different medium. Okay, the first one is from the air. Okay, which we can see actually the spoon is not bending. Okay, so this is from the air. We can see that the air looks like bending. The spoon looks like bending. Okay, so what is changed here is actually the speed of speed. Okay, so speed, that's why we can say we can see that the spoon is actually bending. So question says, state a physical quantity that changes, okay, when the light propagates from water to air. So answer is speed of light. Okay, jawapan dia adalah speed of light. The properties, the physical quantity. Physical quantity ni apa? Okay, physical quantity is quantity that can be measured. Okay, you learn in form 4. The quantity that can be measured can be length, volume, speed. Okay, what else? Temperature, LMT, the base one, LMT, ET. Okay, the length, mass, time, electric current, absolute temperature. Then L, luminous intensity. A, amount of substance. So LMT, ET, law, LE. A is amount of substance. Okay, this is base quantity. So base quantity is the physical quantity, quantity that can be measured. Then we have derived quantity. Example of derived quantity: speed, volume, what else? Displacement, acceleration. Okay, all of that lah yang boleh kita measure. So physical quantity, anything that can be measured. Okay, the quantity that can be measured. Okay, next we have to complete the ray diagram to show the refraction of light that occurs on the spoon. So we have to draw. Okay, saya dah terlukis dekat sini. Okay, so this is a diagram. Okay, actually what we saw is actually the image. So you draw a straight line from the image to the direct to the observer eyes. Okay, yang ni tak ada ya, bahagian ni tak ada. Sebab saya dah terlukis guna pensel tadi. Ini kita padam lah. Nak padam tak boleh sebab saya dah scan gambarnya. Okay, so first you draw the line from the image direct to the observer's eye. Okay, so this is the line that we saw. Okay, and then, okay, actually, where is the position of the object? We know the position of the object is below the image. So, we draw a straight line from the object to the normal line. Okay, where we can see that actually this is the incidence angle I, and then this is the angle of refraction. Okay, so angle of refraction is away from the normal line because this one is air. So the medium air has lower density. So angle of refraction will be away from the normal line. Boleh faham ya? So this is the boundary air and then water. So normal line is given. Okay, what we saw is actually the image. Image sini. Okay, so awak lukislah straight line direct to the eyes observer. Okay, where is the position of the object? So position of the object sebenarnya di bawah kan. So this is the object. Dengan ke sana. Straight line lah. Okay, arrow. Because actually what we saw is from the object. So direction dia from object lah. Jangan pula awak tengok arrow tu macam ni. Okay? Boleh? Okay, so now you go to number 2. Okay, number 2 is photoelectric effect. Okay, number 2 ialah last topic, so saya ignore dulu soalan nombor 2 ni. Kita belum belajar. Okay, now we go to number 3. Okay, for number 3, diagram 3.1 shows a circuit to investigate the conductivity of an electronic component. So, awak nampak saja ni, this is electric component, we call it as diode. Okay, ada triangle and then ada terminal. So this is diode. So which one is positive terminal and negative terminal? Triangle ni positif. Okay, yang ada terminal ni ialah negative terminal. Yang ada straight line is the negative terminal. Okay, so question C. Name the component of X. Right, mana soalannya? Tertinggal lah. Ketinggalan. Page 17 saya terlupa nak scan. Okay, so page 17, question A. Answer kat sini lah, so saya tulis diode. Okay, so 3A, name the component of X. It is diode. How about B1? B1, when the switch is on, the bulb does not light up. So why the bulb does not light up? Okay, so you can see that the negative of the dry cell is connected to the positive of the diode. So negative of the dry cell meets with the positive of the diode. This we call it as reverse bias. So kalau reverse bias, bulb will not light up. So we must make sure that the connection is in forward bias. So kalau forward bias, positive of the dry cell must meet with the positive of the diode. So apa kita nak bagi tahu ayat dia kat sini? Number 2, B1 ni. Why the bulb does not light up? Anyone? Sebab apa? Because the diode is connected in reverse bias. Okay, so the diode is connected in reverse bias. Okay, so question number 2. How does the connection of the circuit in diagram 3.1 needs to be modified so that the bulb can light up? So how? We must make sure that the connection must be in forward bias. So what we have to do to make sure that this connection must be in forward bias? Change the terminal, betul tak? Okay, so what we have to do, number 2. change the terminal of the diode. Atau reverse the terminal of the diode. Or you can say change the terminal of the dry cell, reverse the terminal of the dry cell. Accepted. Both answer. Either you change the terminal of the dry cell or you change the terminal of the diode. Okay, C. Diagram 3.2 shows a full wave rectification. So to remind you back, so we have half wave rectification, full wave rectification. So kalau one diode only, half wave rectification. 4 diodes connected, full wave rectification. Okay, so circuit that consists of 4 component X which are connected to an alternating current supply and a cathode ray oscilloscope when the CRO is switched on. The trace on the CRO as shown. So on diagram 3.2, complete the circuit by drawing the component X in box A. Okay, so in box A, ini box A, triangle, the symbol of diode lah. Okay, so A equals to bahagian D. Kat sini dia punya D. Okay, dia punya direction tu sama macam D because dia parallel. Okay, kemudian kat sini dia punya diode tu. So macam mana bentuk dia dekat bahagian C dan B ni? So you can look at the triangle here. So maksudnya dekat sini pun bentuk triangle dulu. Triangle meets with that triangle. So di sini pun bentuk triangle. Ikutlah. Okay, kat sini awak boleh nampak. Triangle. Sini pun triangle juga. Okay. Kata hidung pula. Okay, boleh nampak ya? So B and C parallel, A and D parallel. Number 1. Ini ialah C1. Okay, sambung. Okay, number 2, we have to trace what is the pattern of the full wave rectification. Okay, so for full wave rectification, saya dah scan ni. Okay, so ni pattern dia. So dia ada, awak ambil dekat 3, dia punya height tu 3 kan. So 3, awak lukis atas line ni, yang ini, ni line ni. Ni line ni kan yang ada black hitam tu. So awak lukis atas tu. Bentuk dia 3. Ini 3. Macam tu. Okay. Yang asal macam tu kan. So ikut je lah 3. Okay. Tapi sebab kita ada apa? Kita ada capacitor. So capacitor is connected. So what is the function of capacitor? Capacitor functionnya to smoothen. Smoothen the waves. To smoothen the current. Okay, so bila smoothen dia jadi straight. Suka gambar yang macam ni lah yang atas yang saya dah lukis ya. So yang bawah tu sebenarnya kita boleh dot-dot-dot lah sebenarnya di bawah tu. Dia padam terus. Dot. Okay, so can see boleh tengok buku macam ni. Ingat balik. Okay, so function of capacitor is to smoothen the current. So the alternating current. So jadi pattern dia macam ni lah. Okay, no capacitor, dia jadi full wave rectification macam ni, full wave rectification. One diode ni 4 diode. One diode, half wave rectification. One diode. So kalau one diode saja, half wave rectification. 4 diodes, full wave rectification. So pattern wave dia macam ni. Kalau dia install capacitor macam soalan ni, dan install a capacitor, dia akan jadi smoothen. Macam tu. Kan? Ingat balik ya. Okay, number 4. Boleh ya? So we go number 4, we go to number 4. Diagram 4.1 shows the process of nuclear reaction that takes place in a nuclear reactor. This process occurs continuously. Okay, karya lawak memang tak masuk ni lah, tapi saya dah ada soalan ni, kita discuss terus. So, what is the nuclear reaction? Okay, kita ada dua. What are they? Nuclear fission and nuclear fusion. So you can see that this uranium is split into 2. So when split into 2, this is nuclear fission. So answer nuclear fission. Boleh? Okay, so nuclear fission. Now, we write a nuclear reaction equation. So nuclear reaction equation. Neutron. So one neutron. Neutron 1, 0, N. This is one neutron only. Okay, plus with, ni before dia split. Plus with what? Ni lah, copy ni. 2, 3, 5, 92 uranium. Okay, lepas tu dia dah split. Okay, split dia jadi apa? You can see, ni kita ada nampak ni. 235.92 uranium. Dia terlajak pula. Bukan, selepas dia split, bukan yang ni. Awak kena tengok yang first dulu. Dia split jadi strontium 9438. So kita tulislah 9438 strontium plus with this one, xenon. Okay, 140, 54 xenon. Okay. Bersama-sama dengan ni ada 2 neutron. So plus 2 neutron 10 N. So dia jadi macam ini. Okay, 10 neutron. Ada neutron, sebiji neutron ni bombard with the uranium 235.92. Then dia split become 2 atom which is 140 and 54 xenon. And 9438 strontium with 2 neutron, 2 biji neutron ni. So equation dia begitulah. Okay. Okay, this one is, I think, easy to understand. C, table 1 shows the mass of each nuclei in atomic mass unit. So based on nuclear reaction, describe in unit of kg. So how to calculate the mass defect? Before minus after reaction. So before reaction, we have uranium. So uranium 235. 0.04395 is the mass of the nucleus. Then mix with the neutron. Neutron kan ada sebiji neutron. So the neutron 1.00867. This is before reaction. Minus after reaction. So minus after reaction dia jadi xenon. What is the mass? 139.9216 plus strontium 93.9154. So jangan lupa ada 2 biji neutron tadi yang terhasil. So plus 2 neutron. The mass of neutron 1.00867. Okay, so this mass is in AMU. So kira lah guna calculator. Baru teringat nak install balik. 235.04395 plus 1.00867 minus 139.9216 plus 93.9154 plus 2 times 1.00867. So answer 0.19828. 19828. Tapi dia nak dalam kg. So times with the unit in kg, the conversion of unit. Mana dia tak bagi kat sini. So kalau dia tak bagi, sebenarnya ada dekat dekat bahagian formula tu lah. Depan tu. Macam ada ke dia bagi kat sini? Tak ada. Tak ada pula. Ada bagi formula je. Okay, never mind. Convert je lah. 1.66 times 10 power of dia tak bagi ya. Okay, so convert dia ialah 1. Sepatutnya dia bagilah dalam soalan ni. 1.66 times 10 power of negative 27. So darab 1.66 times 10 power of negative 27. So jawapan 3.291 times 10 power of negative 28. 3.291448. Okay, times 10 power of negative 28 kg. Okay, so 3 marks. 3 marks. What they will check is this one. And then times the conversion of unit. Then final answer with correct unit. Okay, so dapat sama. Ini rasanya tak susah sebab baru lagi belajar dan awak boleh ingat. Because awak masih lagi fokus dalam kelas saya rasa yang ni. Okay, now we go to number 2. Dapat ya semua? Boleh? Ikut senyap je. Okay, now we go to number 2. Determine the energy release. So energy E equals to mc square. Einstein equation. So the mass 3.291448 times 10 power of negative 28. C is the speed of light. 3 times 10 power of 8 square. Times 3 times 10 power of 8 square. So that's the answer, 2.962. 2.82 pula. 2.9. 623 times 10 power of negative 11. Okay, energy unit in joule. Okay, ya. Okay, at least 2 dp atau 3 significant figures. Okay, next. Diagram 4.2 shows a cross-sectional of a nuclear reactor. Okay, so in nuclear reactor, we have to remember what is the function of the control rod, uranium rod and moderator. So as we know, okay, in the nuclear reactor, okay, there will be chain reaction. Okay, dalam nuclear reactor ni akan berlaku chain reaction. Okay, where a lot of neutron will be produced. Okay, bombard with uranium, again produce the neutron. Again produce the neutron when it bombard with the uranium. Okay, so how to control that neutron? Okay, we have to use the control rod. Okay, control rod ni lah function yang kita kena tahu. So question tanya, how does the nuclear reaction in the reactor can be controlled? So we will use the control rod. Function dia kat sini. How does the nuclear reaction in the can be controlled? Sebab akan ada banyak neutron yang produce in the nuclear reactor. So what we have to use is to use the control rod. So what is the function of this control rod? This control rod will absorb the neutron. Absorbs the neutron. So baru satu markah. Okay, another one. Okay, we know that this process occurs very fast. Okay, neutron laju. So how to reduce the speed? Okay, the velocity of the neutron. Okay, we have to use this moderator. So moderator, slow down the neutron. Okay, satu markah kat situ. Okay, control rod absorb the neutron. Moderator we slow down the neutron. Okay, boleh? Okay, number 5. Diagram 5.1 and diagram 5.2 show two toy cars that are remotely controlled using radio wave from their respective controller. Okay, so frequency, F is the frequency of the radio wave emitted by the transmitter. X, maximum distance of the radio wave emitted by the transmitter that can be detected by the antenna. Okay, so we have to underline the correct answer. The speed of radio wave is, which one do you think? Smaller than, equal to, or? Okay, sebenarnya this radio wave, its speed is equal to the speed of light in air. Okay, so that's why we can hear the telecommunication that come to us when we listen to the radio. Okay, so because the speed of the radio wave is equal to the speed of light. Okay, next. Okay, observe diagram 5. Ini senang. Observe. Okay, that means comparison. Observe diagram 5.1 and diagram 5.2. Compare the frequency of the radio wave emitted by controller A and controller B. Senang lah. So you can see frequency of controller. Ya, apa ni? Alat kawalan A sama je. Okay, so the first one will be the A. The second one will be the B lah. Okay, so controller A has lower frequency than controller B. Frequency of controller A is lower. Boleh? Sampai sini dah senang dah, dan B. Okay, so take the right answer. Which one is the best one? Toy car A still can be controlled even though its distance is 80 meter from the controller. Toy car B still can be controlled even though its distance is 80 meter from the controller. So which one is the best answer? Box number 1 or box number 2? Number 2. Toy car B, betul. Toy car B still can be controlled even though its distance is 80 meter from the controller. Why? Because you can see that the frequency is 4.9 times 10 power of 7. So the maximum distance that it can reach is 90 meter. So if this car is at 80 meter, dia dah dapat sampai 80, B still can control the car lah, the toy car. A cannot because exceeded the 60 meter, dah lebih dah. So jawapan dia yang second lah. Okay, C. Senang. Calculate the wavelength of the radio wave emitted by the transmitter. Okay, so ni sampai formula V equals to F lambda. So we want to find the wavelength. So wavelength lambda equals to V over F. So V because the speed is equal to the speed of light. Speed of light is 3 times 10 power of 8. So frequency of the controller A is 2.7 times 10 power of 7. So ambil ni lah, 2.7 times 10 power of 7. Okay, next is calculator. Okay, what is the answer? 3 darab 10 kuasa 8. Bagi 2.7 darab 10 kuasa 7. Okay, so 11.11. Dapat sama kan? Okay, unit jangan lupa, meter. Okay, so ni makan 3 marks. Kalau 3 marks, 3 marks macam ni adalah dia check kat mana-mana. Okay, biasanya correct and final answer. Dan salah satulah working and then substitution of both controller A and controller B. Salah satu, dia depends on the skema permarkahan pada tahun tersebut. Okay, tak semestinya tiap-tiap tahun sama ya. 3 times 10 power of 8. Dan for the frequency 4.9 times 10 power of 7. Then click your calculator. Answer 6.12. So dapat sama ya. Kalau ada lain beritahu saya. Okay, next. So based on the answer in 5C, state the difference between the wavelength of the radio wave emitted by controller A and controller B. Okay, so the difference here, you state about the wavelength. Okay, which one is longer? So you can see controller A, the wavelength is longer than controller B. So difference between the wavelength. Wavelength controller A is longer. Yeah. Okay. Next. Relate the frequency to the maximum distance. F to the maximum distance of the radio wave can be detected by the antenna from the transmitter X. So if F increases, okay, what happened to the maximum distance? The distance, maximum distance become further, increases or shorter? Increases, correct. So frequency increases. Frequency increases. The maximum distance of the radio wave can be detected increases to. Oh, the bigger the frequency, the longer the maximum distance of the radio wave can be detected by the antenna from the transmitter X. Panjang nak menyalin, so awak tarik sardin lah. Ini sampai sini. Okay, so next, state the relationship between the frequency and wavelength. Okay, V equals to F lambda. F equals to V over lambda. So relationship F increases, the wavelength shorter. So frequency increases. The wavelength is decreases. Okay. Okay, next, number 6. Diagram 6 shows a multi-tap transformer. So, what is the question? What is the type of transformer shown? So, next look at back. So, transformation, type of the transformer. Step up, step down. So, look at the number lah. Okay, number primary coil 1000. Number of secondary coil 200. So from 1000 become 200. So this is step down transformer. Okay, B. Determine the values of NEF and VEF. Okay, so ni guna formula lah. Okay, formula yang ni rasa ada tulis kat depan kan. Kadang-kadang ada yang dia tulis, kadang-kadang ada yang dia tak tulis. Tapi yang ni saya rasa dia tulis. Okay, ada. Okay, electromagnetism topic, so transformer VP over NP equals to VS over NS. Okay, so dia bagi kat dalam buku, dekat formula depan tu VP over NP equals to VS over NS. Formula tak ada markah lah. Okay, sebab kat depan tu dia dah bagi. So what is the VP? VP primary. 240. This is VP 240. VS 60. NP 1000. Okay, so dia minta apa ni? Dia minta NEF and VEF. So V primary 240, number of primary 1000, kan? So V secondary 60, the number of secondary we have to find. So cross multiply, number of secondary 240. Salah, 60. Okay, 60 cross multiply lah. 60 times 1000 over 240. Okay, potong-potong. So guna calculator, so you will get 250. Boleh? Okay, ni baru dia punya number of secondary. Number of secondary is equals to the NEF. So NEF equals to 250. No unit because ini number. So next kita nak cari dia punya, sekejap ya. Saya tak faham kot ni. Tengok sini lah. Multi-tap transformer. Ya Allah. Okay, shows a multi-tap transformer. So if multi-tap transformer ada dua jenis kat situ. So now let's look at number of turns primary coil NP 1000. Okay, and then we have two terminal. So terminal DE and terminal EF kat sini. So number of NDE, so we have to refer to the NDE lah. So dia minta NDE kan. Okay. So 200. And then number of the EF. So how to find? Okay, initially what we have is 250. Tapi number here kat DE ni dia bagi 200. Kat sini dia dah balut. Dia dah coil 200. So kita nak cari baki dia berapa kat sini. So nak cari balance dia kat sini. Kat sini dia dah from D to E. Kalau awak tahu kat sini kan ada DE. D to E total 200. So kita nak cari yang dekat EF ni sahaja. Sini semua 200. Okay. So we have to find the number of EF. So soalan tanya number at EF. So 250 minus 200. Okay, so dapat 50. Ni dekat number secondary kita tulis kat sini 250. So to find the number of EF minus 200. So for VEF, okay, the value will be, okay, initially it is 60. Ini okay? The number of EF, okay, D pergi E tadi tu 200. So bila kita kira number of secondary and the number of turns of coil at the secondary, kita dapat 250. So kita nak EF sahaja. So 250 minus 200 dapat 50. So sekarang kita nak cari yang dekat VF. Okay, that means voltage across the EF. Sini sahaja berapa dia punya voltage. Okay, from from the D to E semua ni, the sum is 48. So nak cari dekat sini sahaja, E ke F tu. So apa nak kena buat? Okay, so semua ni, the V secondary ni given as 60. Nampak tak? Semua ni, semua kat sini ni, all of 60 volt. Okay, then dia bagi DE 48. So sini 48. So berapa dekat EF ni? Minus sajalah. Okay, so VEF equals to 60 minus 48. Boleh? So answer 12 volt. Okay, so soalan ni kita tak pernah jumpa lagi bentuk dia kan dalam mana-mana buku latihan. So ni kita jumpa. Okay, boleh everyone? Okay, thank you. So now compare. Okay, based on diagram 6 and the answer in 6B, compare NP, NDE and NEF. So start with the biggest one lah. The biggest one will be the number of primary. Number of primary is 1000. Dan number of DE DE kat sini daripada awal ni sampai habis ni, number of DE is 200. Okay, mula-mula start with 1000 followed by 200. So, number of primary is bigger than number of DE. Okay, number of EF is the least one, 50. Macam ni lah kita tulis, number of EF. E. Okay, compare the ratio of VP to VS with the ratio of NP to NDF. Ratio VP to VS. VP 240. V secondary equal jawapannya. Compare the ratio of VP to VS with the ratio of NP to NDF. NP to NDF. NDF 200 greater lah. Okay, the ratio. Bandingkan nisbah. Kenapa dia jawapan dia sama? Bukan you calculate first the ratio. So VP to VS, VP to VS. What is the ratio? So VP the value is 240. V secondary 60. 4 to 1. Both 4 to 1. Betul? Okay, 4 to 1. 60. Okay. NP to NDF. NP to NDF. What we will get? Number of primary is 1000. Number of D to F tadi ialah 200. 50. Okay, so find the ratio 1000 divided by 250. So dapat 4. So dapat 4 juga. 250 divided by 250 dapat 1. Betul? So awak nampak dia tanya compare the ratio. So for VP to VS 4 to 1, NP to NDF pun kita dapat 4 to 1. So the ratio is same. Dia nak ni je same. Yang VP to VS, NP to NDF ni tak perlu. Tapi kita kena kira dulu sebelum kita dapat dia punya ratio tu. So soalan tanya compare, same lah. Now compare VP, VDE and VEF. VP 240. VDE D to E and F. D to E tadi ialah 48. Kita gambar D to E dia bagi VDE 48. VEF 12. So dia suruh compare. So VP greater than VDE greater than VEF. This is the answer. Kan? 240 and then 12. Boleh? Okay, next. Based on the answer in 6C, state the relationship between the number of turns of coil and the value of voltage. So, relationship. Okay, higher, higher, lower. Okay, higher, lower. So, the number, the bigger the number of turns ataupun the number of turns of coil increases, what happens to the value of voltage? Increases too. Betul tak? So, saya rasa awak tahu ni. Okay, the bigger ataupun the higher the number of turns of coil, comma, the higher the voltage. Okay, awak tengok kat primary. Primary, each number of turns 1000. The value of the voltage at the power supply at the primary, which is 240. When it comes to the secondary, the number of primary coil become less, which shows that the value of the voltage reduced too. So inilah dia punya relationship. Boleh ya? Okay, boleh lah tu. Okay, now E. If the power supply in primary coil is replaced with direct current power supply, state the value of the current in secondary coil. Power supply, primary coil replaced with direct current. Apa akan jadi pada current that is flow in the secondary coil? 0. Okay, tak ada nilai ya, 0 ampere because diperlukan alternating current. So 0 ampere. Atau tulis 0 saja pun boleh. Okay, number 7. Diagram 7 shows an athlete spinning a hammer in an in hammer throw sport event. So the centripetal force acting on the hammer when rotated is the tension of the spring. So dekat sini inilah dia punya centripetal force. Okay, so what is mean by centripetal force? Okay, kita tahu centripetal force is the force that makes this hammer is always in a circular path. Dia akan berpusing kan? Turns with direction which always towards the center of the this man. Okay, tapi dia bukan tulis man lah. Kalau tanya centripetal, center of curvature. Okay, a force that makes an object to follow a circular path with direction always toward the center of curvature. Okay, a force that makes an object to follow a circular path with direction always towards the center of curvature. Okay. B, on diagram 7, mark the direction of the centripetal force acting on the hammer. So I show you already the direction is always towards the center. So at least you must show the direction and arrow which towards the man, to the athlete. Okay, so jangan lupa labelkan. Okay, mark the direction of the centripetal force with F. So tak arrow, letaklah F. C, the hammer of mass 4 kg is rotated in a horizontal circle of radius 1.6. So M4 R 1.6. Next you can see what is the formula. You are given V to the linear speed, which is the V. 1.6 R mass M. So centripetal force formula. Okay, awak dia bahagialah bagi siap-siap ya. So centripetal force formula mv square over R. Masukkan saja dalam formula tu. So mass for V25 square dan radius 1.6. Okay, kemudian calculator. So jawapan 1562.5. Okay, don't forget this is force, centripetal force, unit must be in Newton. Okay. Baik ya. Okay, now kita pergi kepada D. Table 3 shows the characteristics of the hammer throws FGH involved in hammer throw sport event. Okay, based on the specification in table 3, state the suitable characteristics of the hammer throw that has the highest string tension when it is rotated. Give reason. Okay, for the suitability. Okay, length of the steel string. Okay, higher or shorter? The length of the steel string. Short. Why short? Because it will produce high centripetal force. Okay, the reason, high centripetal force. Okay, so the length of steel string tu yang ni kan tadi, man tu. Okay, so force dia kat sini. So kalau kita relate dengan formula F equals to M V square over R. So length of the steel spring shorter, so produce high centripetal force. Okay, next, linear speed of the hammer when it is rotated. Tadi dia sebut high, betul lah high. Kena high speed of rotation when it is rotate. Okay, reason F, kita masih lagi, you can use the formula F equals to mv square over R. Okay, so V, they ask about the V, the linear speed, the V. Okay, V higher. So, kita boleh guna ni F ni as our reason. F also higher. So, F tu apa tadi? Centripetal force. So, the reason, high centripetal force. It will produce high centripetal force. Ada soalan? Cikgu, boleh ke reason dia sama macam yang tadi? Boleh. Okay. So, formula ni sebenarnya will help us to find the reason. To state the reason. Okay, sebab biasanya dalam formula tu ada physical quantity. Dalam formula ada physical quantity. That physical quantity will be used as our reason to mention in the question. Okay? Boleh? So kat sini kita boleh gunalah VF. Relate. Tadi length of the steel string. The length of the steel string is actually referred to the radius. Okay, now E. Based on the answer in 7D, which hammer throw has the highest tension of the string when it is rotated? So which one do you think? Okay. Kat mana? F, G or H? Okay, speed must be high. And then length of the string must be shorter. So jawapan dia H, betul. Okay. Senang kan? Okay, 8. Diagram 8.1 shows an airplane when it is at cabin altitude, which is 2,134 meter, and when it is at cruise altitude 10,973 meter. At cabin altitude, the pressure inside the cabin is 77.9 kilopascal. That is equal to the atmospheric pressure at equivalent altitude. The atmospheric pressure drops to as low as 22.8 kilopascal at altitude of 10,973. So define atmospheric pressure. Okay. So ada definition yang kita boleh guna formula. Ada yang kita kena hafal lah. Okay, tapi macam atmospheric pressure ni tak ada kaitan dengan formula. So, it is actually the pressure due to the weight of the layer of air acting on the surface of Earth. Okay, B. How might the human's rate of breathing change at high altitude? So he asked about the how humans breathe. Okay, change when it goes to the high altitude. So usually when we go to the high altitude, okay, our breath become higher or lower? Kalau naik panjat bukit tu, kita punya pernafasan tu, makin tinggi ke makin rendah? Susah ke senang? Increases. Susah kan? So, bila susah means the rate become high. Okay, so at high altitude, increases. Okay, at high altitude, the human's rate of breathing increases. Humans rate of breathing increases at high altitude. Okay, why? Reason, dia tanya reason. Explain your answer. Okay, paling senang because kita tahulah. Okay, when we go for hiking, udara nipis, betul. Okay, when we go to the, kalau kita naik panjat bukit 300 ataupun bukit Wong Kubosu tu lah paling dekat kan. Okay, the air reduce. So the percentage or the atmospheric pressure has low. Okay, reason the percentage of oxygen in the air become low. Or thin air. Thin air causes the atmospheric pressure to become low. Okay, dah. Okay, now see. Diagram 8.2 shows an airplane uses air that enters the engine to provide air to the cabin during flights. Okay, the air is then processed, cooled, and finally piped into the cabin. Okay, the pressure in the cabin is kept between 75.8 kilopascal, okay, to 2.7 kilopascals to ensure that the passengers and flight crews can breathe easily. Okay, so what is the method can be done to ensure that the passengers of the airplane get enough air, okay, at high altitude? Okay, so of course they have to use dia macam mesin, bukan mesin lah, okay. Macam engine tu to make sure that the air can flow through the air which contains oxygen can be flow into the cabin crew dalam airplane. Okay, so what we have to do? Okay, first to increase the rate of air absorption through the engine. Okay, so the first method to increase the rate. Okay, metodnya kena increase lah the rate of air absorption through the engine. THROUGH. Okay. ROUGH through the engine. Okay, reason to provide more air into the airplane cabin. Okay, suggest action to be taken if there is passenger suffering from a lack of oxygen absorption in his lung during the flight. Ini kalau jadi stewardess ni, yang steward, dia kena fikirlah. Okay, apa nak dibuat? Biasa kecemasan apa dia orang kena pakai? Kena pakai itu kan, topeng tu. So, use the oxygen mask. Kalau awak tengok cerita-cerita orang putih tu, biasa ada kan, mereka kelang kabut pakai oxygen mask. Kenapa kena pakai oxygen mask? Sebab nak dapat oksigen lah kan. Okay. So to supply the enough oxygen to them. Okay, number 3. Diagram 8.3 shows a side view of an airplane window design proposal. Okay, so take the correct design of the window to create a safe pressure difference between the air inside and outside the airplane. So, mana satu? Straight sahaja ke? Ataupun inside the airplane, curve outside the airplane, dia macam ni, the second one, ataupun yang macam yang number 3 ni. Second. Okay, second betul. Okay, inside the airplane dia macam curve. Kan outside pun curve lah, dia ikut follow yang inside the airplane. Okay, so kenapa? Okay, design of the window, justification. The design of the window resists deformation caused by the extreme difference in pressure. Produced greater force. Acting from inside. On the airplane compared to outside. Okay, pressure inside actually greater than outside. So when we have to create design dalam ni, kita tahulah dia mesti curve sebab kat sebelah dalam inside the airplane must be greater force. So dia lebih curve lah di sebelah bahagian dalam, okay, berbanding di luar. Okay, soalan question number 9, 10, 11 continue tomorrow. Boleh? Besok okey ke kalau saya buat? Sebab hari Isnin awak ada exam. Kalau tak okey, tak apa. Boleh? Okey. No problem, right? Sebab English saja kan? English cuma nak baca yang bahagian apa dia punya time teacher samalah, boleh? Saya nak pagi. Tak nak pagi. Saya tak nak pagi. Pagi saya nak pergi pasar dan macam-macam aktiviti saya. Malam okey? 9 hingga 10.30 ke tak boleh? Nak awal sikit. Boleh je lah ya? 9 to 10:30. Okay, class. Thank you very much. Okay, thank you. So, children. Hanani. Okay, terima kasih semua.